Hi guys, today we are going to see about univariate, bivariate and multivariate analysis. The name itself says univariate is of one variable and bivariate is of comparing of two variables and multivariate is more than two variables. This is the basic step in the EDA which gives a clear idea to us whether the model should be built in a linear model or in a non-linear model. So this gives a wonderful visualization and it gives a proper analytical output that how our data is being divided and how our data looks like. So this is the basic process. For example, if we have data, weight, height, and output. See, if I have my weight as 100 kg and height is 180, then it is obese. If my weight is 50 and my height is some 150, so this is fit. If my weight is somewhat 80 and my height is 160, then it is slim. I'm just giving this for an example so you could understand what I'm coming to say. If there is a data set like this, we have to find the correlation. Univariate analysis. Univariate analysis just takes a single thing because it is uni. So it takes only height or it takes only weight and then it makes an analysis. We have to make an assumption that I will give an intro about bivariate. So bivariate is height is to weight. We will be plotting uh, this is the y, this is the x. So we can plot the height in y-axis and weight in x-axis, and we could have a graph like this somehow. But in the case of univariate, we are going to assume that if we take height, it is to be compared with 0. It will be making some categories. From here to here, it is slim. From here to here, it is fit. From here to here, it is obese. Like that, it would be making a group here. So in this way, the univariate analysis is done. I will be explaining this you using the code. We will just look into the concept right now. So this is bivariate. This height is compared to width. Only two components called height and width. It is easy to be compared with the graph. But if we have three-dimensional data, then okay, fine. If I'm having age when compared to height, width, I'm also having age. It is okay because human eyes could process only three-dimensional data. But if we have more than three dimension, say if we have address, if we have the area, how we can do analysis on that? So in that case, multivariate analysis is done. This is done using pair plots. We will be looking into the code. Here we have our Jupyter notebook. We are importing the required libraries, NumPy, Pandas, Seaborn, Matplotlib, and the warnings. We are going to import a dataset which is of diabetic readmission dataset. It is available in Kaggle. Now we will be loading the dataset. Now we will be checking it df.head. See, we have this is a great dataset which consists of some 50 columns and some 10,000 rows, I think so. The target column is readmitted. The dataset, I will give you a short note about this dataset. This dataset says after getting the treatment, after getting the analysis, after doing all such things, whether the patient is getting readmitted to the hospital or not. That is below 30 days. If the person gets below 30 days, it will be marked as below 30 days in the readmitted column, or else above 30 days, it is mentioned as above 30. If they are not getting readmitted, it is given as no. So this is the target variable we have here. We are going to perform our analysis based on this target variable. So this data set is somewhat clumsy. We have to do some data cleanings, then we have to proceed, because in this age column we don't have a proper age, so that we will be making some data cleaning process which is not relevant to this video. Okay, now we have cleaned the race column and the age column. Now we are going to perform univariate. I have to classify these three things: no, below 30 and above 30. So I'm going to write a code: data frame df readmitted equal to t. I'm going to check that, sorry, so which are all above 30. So I'm just doing it. See, we get the data. We are getting above 30. This is greater than 30. I will be saving in G30. Same wise, I'm going to do for other things. This is for less than 30, L30, and then for no. This is done. Now we are going to plot this. ELT dot plot. First, this is less than 30, so I'm taking this. This we are going to take age. We'll be using np dot zeros underscore like, and then we copy the same. See, I'm giving this because we are going to take this less than 30, that also for the age. This is the univariate we have taken, but as said before, we have to take the x column. As said before, we are considering the y column as 0. So we have to say that zeros, like if we have some 100 rows regarding this age, we will be saying that for 100 rows you take it as 0. The same for others. And plt dot show. So we'll be getting this. For bivariant analysis, we are having an inbuilt function, face grid. So facet grid, SNS dot facet grid. I'm giving the whole data set. Q is readmitted. That is my target variable. Size is for the size, and we are getting a map here. We are going to map that whenever you plot this thing, you just plot it as scatter plot. So we are going to compare the race and age here. We have the race and age. So we are going to compare this and add legend. See, this is the output we get. We have Caucasian, African American, other race, Asian, Hispanic. Green is of greater than 30, orange is of less than 30, blue is of no. So we are having more green. If we go to multivariant analysis, in pair plot, we will be getting for all the variant. In pair plot, we will be getting for all the variables. Make short it, and we have to proceed. So I will be taking all equal to, I will be making a list of age. So we have taken age, race, number of diagnosis, and readmitted. Here we are going to plot the pair plot. Just simply we will be saying SNS dot pair plot. This is our data frame, and in the data frame we are making a separate columns, and hue is readmitted. This is the target variable, and size is 5. It takes some time. See, this is the pair plot. We will be having age, number of diagnosis, age, number of diagnosis. So if age is plotted to age and age, it will be getting some histograms. And the same thing it does for everything. I've just filled the data set and I've given this. So in this way it is plotted. We do all this for finding the correlation between the data. Yesterday we have seen about Pearson's correlation. It is the best way for finding the correlation. Correlation says how two variables are correlated with each other. In that way, it is very useful to build the model. Whether it is a regression model, it is a logistic, this both comes in the linear model. Whether we're going to perform linear model or non-linear model. Non-linear model, we can take it as KNN, the K nearest number, and then decision trees. So there are many things we can take ADA boosting, GXB boost. So like that, we will be doing many things. So this analysis gives a preface whether which should be done for which data set. See, we don't have any correlation between these. This plot says that we don't have any correlation. So better we could go for classification. That would be the great way because this is of categorical data. And by this result, we could go for classification. These things are derived from this univariate, bivariant, and multivariate analysis. Thanks for watching.